We are going to be dealing with our inverses that we dealt with here yesterday first. So on here we've got find the inverse of each function. And what I did to try and help out is I put the directions on what we're trying to do here. So my first job is to switch x and y, and I put the, remember here, that f of anything, g of x, doesn't matter. It's really just a fancy way of saying y equals. So if you want to just cross out those of x's and put y equals for that on the inverses, that's okay. And then solve for y using opposites. So when I do this, my first job, whoops, that's going to have to be y. My apologies there. I didn't get my own switched around there. So switch those around. And once I do that, again, my goal is to get that y by itself. But in this case, I have an issue. It's an issue we ran into yesterday. Y is stuck with this plus 2 in radical jail. So my first job is going to have to be to get radical jail out of it. We got to break them out. So my opposite, my inverse of doing a cubed root would be to cube both sides. And if it would have been a square root, we'd have squared both sides, and so on and so forth. So over here, the inverses would cancel. Over here, I've got x to the third. And then just like we would on any of these, now that these guys are out of radical jail, my whole job is to isolate my y term. And I do an opposite to do that. Flush. And once y is by itself, we're okay. So the biggest thing I think I'm seeing with some of you that were talking with me is we got to get over the notation stuff. It's not the algebra that we have, that hopefully in the most part, that we have the trouble with. It's, okay, how's this notation thing work? So again, we can make that y equals. First job, switch the x and the y. And so just like I would with any Algebra 1 type problem, my first job is to isolate the term that the y is in. So I want to get the fraction by itself. So I do the opposite to what's going on out here. And again, that's x minus 1. It's not negative 1x. We're not multiplying them together. And now we get into a little different of a situation. In kind of thinking how some of you would think on this, I'm thinking, okay, some of them are going to want to add 1 here. But here's the problem. This is in the denominator. So normally when we have something in the denominator we need to get out of there, we just multiply both sides by it. But that may not seem like a normal thing for some of you here to think to do. But it is what we're going to have to do. Because the only way I can get this out of the denominator is to multiply it to both sides, which will bring it back up top. Now it's going to give me a very weird looking expression here for a moment. So you're like, okay, like, do I box or foil that out? No. Okay. Like, well, what do I do then? You know, I'm kind of stuck. I'm going to take the part that's got the y, because again, that's what I'm trying to solve for. That's what I got to keep focusing on. What do I have to do to get the stuff away from my y's? Well, right now I'm multiplying it by this x minus 1. Okay, there's no plus or minus in between them. Flash. So we're going to divide by the x minus 1. And yes, we're almost there. Okay, I'm just going to rewrite this for a second so we can see what's going on. Okay, so all we've done so far is keep doing opposites to move things around. It may be taking more steps than we like, but sometimes we got to go that route. And so I got one step left to get y alone, and that's to add 1. And again, not to my numerator, I'm going to have to put it on the side because this is a fraction. Oy. Now again, that's more of an extreme than anything else. Okay, this would be as bad as it gets, and it usually isn't going to be quite this bad. Okay, it's usually going to be much more straightforward. And that's going to be the case with 3, 4, and 5. That's why I left those for you and kind of worked through these first two together. Okay? But again, go through, turn those into y equals to make your life a little easier. And then we're just going to switch x and y, solve for y, kind of like we do algebra 1. Okay? So that's looking at page 1. Just practice there. As we turn with our inverses, find the inverse of each function. Then, graph the function and its inverse. Okay, we've talked about this a little yesterday with the matching problems and that last problem we did in the examples. So I get this part here. So my first job, it says, find the inverse. Okay. So I'm going to switch my x and y. And I'm going to work on solving for y. And it's a lot easier this time with this one. Get my y term isolated. What's outside the box? The minus 15. I got to do the opposite. And so once I get that done, my last step is going to be to divide all of my terms by 5 to get y alone. Now, if I punch it into my calculator or I look at it and say, hey, that's going to come out decimally, I'm going to leave it as a fraction. We don't want to play with decimals, especially when we're graphing. Because I'm going to make this more complicated. And 15 divided by 5 is 3. Okay, so now I've got my two expressions. So it says now that we want to graph the functions. Okay, here's where I'm going to have an option. If I'm comfortable graphing lines when they're in slope-intercept form, like these are, that's fine. I could just jump in, I can start plotting points and working that. Which some of you will look and say, ooh, that first equation is going to be kind of hard because my graph goes down to 6 and that says 15. I'm with you. So if you're kind of wondering, am I going to have to deal with starting my graph way down here in the middle of nowhere? Not necessarily. What I could do instead is I could type that into the y equals of my calculator and pull up the chart and go, okay, well, 0, negative 15 isn't really going to work well on this particular graph. Negative 110, 1, negative 10, I might be able to pull off if I come down here a little ways. But you could actually pull this up and just start using some of the points that way to be able to draw your line. Now, if you know your stuff with your slope-intercept, you make the first point, you just go up 5 and over 1. Up 5 and over 1, so that's my slope. Up 5 and over 1. And I get that first line drawn in. Okay. Now this inverse, when I put it in, and this one I think I can do without having the calculator, but I'll show you the other way just in case. Plot my y-intercept first, and then again, rise over run. So I'm going to go up 1 and right 5. And if I run out of room, I just do the opposites of both. Down 1 and left. 1, 2, 3. And what should happen, and we saw this yesterday when we got to those ones at the end, they should be reflecting each other over the line y equals x. Now, you're like, okay, well, how would I know where that line is? Do I have to draw it? I don't have to draw it, but the line y equal x just means that. When y and x equal 1, 1, 2, 2, 3, 3, 4, 4, and I could kind of go through and make a line of it just with those points that are the same. If I would fold my paper on that then, okay, notice these points are the same distance away. It's like a mirror image. Same thing with these two, same thing with these two, and it would keep going and going if I had a bigger graph. So that's basically what I'm going to see when I'm doing these. I'm going to see a reflection based on this kind of being my mirror, my center line with that. You're like, okay, that might be all right. Maybe. So the other one I want to do, kind of get you set up here, is 7, because again, fractions can be kind of interesting at times. So we'll get that to y equals. So my first job, switch x and y. Now I notice this time, to get y alone, I got two things going on. I got this plus 4 and I got this divide by 2. Well, does it matter which one I do first? The answer is yes. If there's a fraction, that's got to be dealt with first. So, the opposite of divide is to multiply. And now I just keep telling myself, okay, get y alone. I'm adding 4 to it. Got to do the opposite. And again, the 4 doesn't have an x, so I can't combine here. That's not going to be negative 2x. They're on the same side, but they got to stay separate. And then we divide everything by 3. And again, if things get decimally, we're going to leave them as fractions. Now, don't worry. We are not going to cause a problem here. When we go to graph, we've got some options. But that would be my inverse. So, when it comes to the graphing part, okay, we've talked before about how having things in a big fraction doesn't necessarily make it easy to graph. So what I'm going to do here is, I'm just going to rewrite this. 3 over 2, if I try to put it into my calculator. Okay, 1.5, we don't like the decimals. So we'd have 3 halves x, and then 4 divided by 2 is 2. Okay, that's my original problem. So I can either say, okay, my y-intercept is at 2, and then I'm going to go up 3 and right 2, or I do the opposite of both, which would be down 3 and left 2. Or if graphing lines isn't my specialty, doesn't have to be, I'd have to put any fraction in front of x in parentheses so the calculator knows that's what I'm up to. And I could pull the chart and notice 2, 5, okay, 0, 2, -2, -1, -4, -4. I can let the calculator help me get my points. Either one, A-okay. Oh, there it is again. Okay. And then it would be the same thing for the other one. And it might actually be easier for you to go to the calculator, but I'm going to try and show you here. Because I always like to get you as much freedom as you can. Because you're like, well, wait a minute. 4 divided by 3 is like 1.33. So how would I graph that? Well, it's negative 1.33. So I'd go in between -1 and -2. Put a dot. And I go up 2 and right 3. So I'd go middle, middle, right, middle, right, middle, right, left. Now again, if that, having to deal with going in the middle of those, kind of confuses you doing the slope, we got a plan for that. If I'm going to type this in, I just make sure that my fractional parts are in parentheses. And I can absolutely pull a chart. And so on this one, actually, I could get whole numbers to work with. -4, -4. -1, 2. 2 is 0. And actually just connect those, but they'd all be on the same line. They're all on the same points as I'm doing these, okay? So the calculated graph is okay, slope-intercept form is okay, but I got to find my inverse. Okay, just kind of get some opposites. Let's see what else we got for fun here. State if the following are inverses. Reminder, and this is another one that we were having some fun with yesterday. Does f of g of x equal x and g of f of x equal x? Really, all you're basically doing, okay, is you're going to plug g into f, see if it equals x. Then you're going to plug f into g, see if it equals x. So we're going to do 11 and 12. I want to do a couple of different types here. So my first one, and I'm not even going to write it this way. This is where I think we were getting into trouble yesterday with the notation. So for my first one, okay, we're going to plug g into f. That's what this is. So here's my f function. So I'm going to start writing this, but when I get to the x, I'm going to replace it with what I've got in here. And then write the rest of my f function. Okay, so I took the x out, replaced it with what's in the parentheses. And now I'm going to simplify what's there. So I look and I'm like, okay, cubed and cube root cancel, which leaves me x minus 2 plus 2, and negative 2 and positive 2 cancel. Okay, I get my x. So my first half here, g into f, worked. Now since that worked, I have to check the other one, which is this one, which says we're going to plug f into g. So I'm going to start to write my g, but I notice right away, okay, there's my x. I got to replace it with this stuff. So this took the place of my x, but then I still copy the rest of it like it is there, because the x is the only thing that got replaced. So what's that start to look like? Well, when I look in the parentheses, I see some things I can simplify. This plus 2 and minus 2 would cancel. So that leaves me with this, and cubed root cancel. I get x, and yes, they absolutely are inverses because they got what I needed. Now, is that going to happen every time on these? Not necessarily. So if you ever get one where it doesn't equal x, you're just going to be done. So let's see if that happens to be number 12 here. All right, so first job. Okay. This one into this one. So h into f, or in other words, f of h of x. So I start writing f. And when I get to the x, again, I'm going to plug my h value in, but that's the only thing that's going to change, and that's why I'm using the different colors, so it kind of jumps a little more. X out, h function in. So now I got to work on simplifying this. So I'm going to distribute my 3. And I'm going to work on simplifying. So let's see. Negative 4 minus 15. Negative 27x minus 19 over 2. That's as far as I can simplify this. And that certainly does not equal x. That equals a lot more than x. So I don't have to even do the other one, because that does not equal just plain old x. Okay? Once you get either of them that do not equal x, it's no. So let's say the first one would have equaled x and the second one doesn't. Still is no. but I've got to see if they're inverses that way. So still do the plug-in. We just got to see if the opposites equal x, and if they don't, we go on to the next one. All right, let's see what else we got to play with here. Oh, the factoring. So this is kind of a flashback to earlier in the week. Kind of gives us a nice overview. Again, hopefully you've got your blue sheet. There's more blue sheets in front of the folder if you need them. We have 4 terms. We pair them off. And we're going to look at each pair individually. And what I'm looking for is, what do they have in common? Well, I can divide a 2 into each of them. And they both have r's, so I'm going to take the smaller exponent of my r's. And once I pull that greatest common factor out, (14 divided by 2 is 7. I got 2 r's, I need 3. And then here, 2 times what is 2? That'd be 1. And I already got both my r's. So I've got in the back of my brain, okay, when I do the second one, this better be what's left over, or some didn't quite go right. So I look at that second pair. I go, okay, 49 and 7. Well, they're both divisible by 7. And again, if I wasn't sure, pull out your multiplication chart and look for a column or a row where 7 and 49 are. That'll tell you. And they both have a negative, so I'm going to pull negative 7 out. 49 divided by 7 is 7. Still have my r. Negative 7 and negative 7 divided gives me a positive 1. Got what I was looking for. And so now I got one step left to write this in its answer form. I take my greatest common factors and put them together. And I take my common factor and put them together. So that's how the ones in that section kind of play out. Normal factoring. Remember, look for common factors first. So 19. Ooh. They both have an x. I can pull an x out. So that'll reduce that by 1. And that'll take the x out of that one. Now, before I circle it and say, I'm good, remember, look for clues. If you see a square or a cube, you may want to take a quick glance and go, ooh, is that a perfect cube? Oh, it is. Okay, 5 cubed is 125. So, what do I cube to get each one? Jotting it down is a good idea. And now I'm just going to pull my help sheet out and go, okay, here's my difference of cubes. So first, and it's minus, so it's this one, minus second. When I move forward, I square my first term. This is why I write them down separately. Plus the product of my 2 terms. Plus my second term squared. Nice thing with cubes, never have to worry about breaking them down anymore. That's just going to be the end. So I can kind of see how this works. Oh, we're down the home stretch here. We're running out of factoring ideas. All right, factor completely. Just a couple left here I'm going to do with you. Again, always look to see if they have something in common. If in doubt, try to divide the smaller number into the bigger one. 125. And just like we had on the last one, I notice it's a cube. I notice 125 is a perfect cube. We just kind of hit upon that. So basically, I'd be running through that same process that I just did on the last one. I'd take my little help paper out. M minus 5. Square my first term. Switch the sign. take my product, and again, these are all on your blue help sheet, so if you need to reference it, do so. Plus 25, and I work on my cubes. And yeah, there's a lot of different things going on, which is why we're taking so much time and kind of practicing in here to make sure we're set. Okay, last two we're going to do are 26 and 28. 26, anything in common? 2. Okay, so 8 divided by 2 is 4. Negative 2 divided by 2 is negative 1. All squared. I wonder if it's a difference of squares, because that's on here. 4, yep. So I run that same idea. What do I square to get each term? But now remember, these aren't cubes. So when I'm doing squares, first plus second, first minus second. First plus second, first minus second. Happy camper. But again, if you don't practice that, that's not gonna click. And then finally, I get to this last one. Nothing in common. That's kind of a bummer. So it looks like we're going to have to go sliding and dividing here. And this particular one, that's a pretty big number. So more than likely here, what I'm going to get stuck doing, sometimes we got to do it, is I'm going to grab my calculator, and I'm just going to start dividing some smaller numbers in, trying to get myself a list here so I can start to narrow down where this particular answer is going to be. And after I've done these for a bit, and you'll notice a lot of these are going in, I'll probably do it until I hit my first decimal. Okay, now I'm going to stop for a second. So what do I know? Well, I know since it multiplies to a positive, the signs are going to be the same. And I know by the middle, they're both going to be negative. So I'm looking for two numbers that multiply to 420, but add to 52. So notice something. As I come down my list, if I start adding these together, notice the sum keeps coming down. And it's coming closer to 52. So I'm getting there. It's taking me a little bit longer than I had hoped. But finally, I get to a point like, hey, 52. Woo! Finally, I found my sum. It took me 7 tries, but I got there. 10 and 42. Give yourself a quick pat on the back, but you're not quite done. That 7 that we had before has to come back in. And I notice one other thing as I do that. M times M would get me M squared, but this is a higher order. So since I want it to be twice as much, I got to make sure I get my squareds in. If I do my division, 10 divided by 7, and I get a decimal, swing that bad boy back to the front. But if it goes in nice, 42 divided by 7 is 6. Sweet. We're set and ready to go. Okay? So these, again, a lot of this is unusual. Some of it has some connections, but not all of it. It's new. You've got to practice so it becomes normal. We've got one more section to do early next week on division. We're going to do that, and then we'll go into review mode again, and we'll have that quiz on Thursday. But you've got to prep. You can't just do the ones we do together and expect you're going to know how to do this. So work on that a bit, and we'll see some more next time.